5 facts Lidar companies don't want you to know. With smart cars entering series production, more models are equipped with Lidar. We start to hear about new terms. Solid state, MEMS, 1550 nanometers, and region of interest. However, most cannot tell the difference between real cutting-edge technologies and advertising tricks. Today, let's walk through the basics of Lidar by answering 5 questions revealing some facts that Lidar companies don't want you to know. Question 1. Are solid-state Lidars really solid-state? Answer: most of them are not. Solid-state means no moving parts. There are 3 solutions for automotive Lidars today: MEMS, 2D scanning mirror, and 1D rotating mirror. They all steer the laser direction by moving mirrors. As long as there are internal moving parts, it is not technically solid-state, but hybrid solid-state. Only this type of Lidar that doesn't move at all is fully solid-state. But today, it has not been mass-produced for automotive applications. Question 2. Is 1550 nanometers better than 905 nanometers for Lidar? Answer: no. They each have pros and cons. First, saying 1550 nanometers is safer for the human eye is incorrect. Any wavelength of light in excessive amounts will harm your eyes. In fact, all automotive Lidars that comply with Class 1 laser standards today are safe. Second, no wavelength is better than the other. It's the system design that matters. The 1550 nanometer system has better ranging capability, while the 905 nanometer system has higher resolution. 1550 nanometer systems have less sensitive receivers, thus requiring higher power transmitters in order to reach the 200-meter detection range. This results in overheating, which is tough to solve. Question 3. Is regional high resolution the same as high resolution? Answer: certainly not. Unlike overall high resolution, regional high resolution applies only to a region of interest, or ROI. However, sacrificing overall resolution in exchange for an ROI may be a bad trade-off. If we look at car cameras, it is hard to imagine a situation where one area is clear while the rest are blurry. Because safety is not only about what you see, but also what you don't see. Would you choose a taxi driver who is well aware of the surroundings, or one who is only good at staring ahead? Question 4. Is seeing farther always better? Answer: seeing farther doesn't mean seeing clearer. This is what a Lidar sees: objects outlined by laser points, helping cars to perceive the surroundings. The farthest point a Lidar can detect is called a single-point ranging, which is the ability to measure distance. The density of these points constitutes the resolution, which determines whether Lidar can see clearly. Only specifying max ranging capability is irresponsible. Like in this image, only a few points are visible. Can you tell what the object is? What if we increase the resolution? What about now? Therefore, a good Lidar should not only be far-sighted, but also clear-sighted with high resolution. Question 5. Are more laser channels better? This is true. The number of lasers vertically in a Lidar are called channels, such as 16 channels, 64 channels, 128 channels. More channels means better results. But what if the Lidar doesn't have so many lasers? For example, this hybrid solid-state Lidar has to simulate vertical scanning, using just one or a few lasers to achieve the equivalent effect of many channels. But this scanning method causes problems like irregular scanning patterns and stitching distortion. A real high channel count Lidar has more benefits. For example, a genuine 128 channel Lidar has 128 laser transmitters and receivers. It It generates clear scanning patterns by sweeping across the entire field of view. All 128 lasers work independently. When one laser fails, it won't affect the overall perception, unlike the simulated channel scanning method. Of course, integrating 128 lasers into a small, compact LiDAR requires strong ASIC technology through R&D. These are the 5 facts LiDAR companies don't want you to know. Let's recap. First, as long as there are moving parts in the LiDAR, it's not fully solid state. Second, 1550 nanometers and 905 nanometer LiDARs each have pros and cons, but they are both safe for the human eye. Third, ROI does not equal high resolution, as you don't know where an accident might occur within a field of view. Fourth, just seeing far is not enough. A LiDAR must also see clearly. Fifth, higher channel count means higher resolution, but not exactly true for simulated channel solutions. Lidar is becoming a standard component for smart cars, and now you know the 5 insider secrets of LiDAR industry.